Hello, Calculus, and welcome to Chapter 5. We are going to be graphing lots of different graphs, all types, using derivatives. So we'll use the first derivative to find turning points, the second derivative to find inflection points, and then we're going to graph our graph based off of this information. Now, some of these you'll know, and we're going to use our previous knowledge to help us through this. And this very first section is increasing and decreasing. So is the graph going up or going down? So I want you to pause right now and actually do the first page of your notes. So when you went through here, you should have labeled these and you should have said, hey, A is, let's get my pen out here. You should have said this one is increasing, 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 right? Because you always read a graph from right to left, it's always going up. And the bottom ones were decreasing, you're going down, right? Going down, decreasing, and going down. That should not have been too big of a stretch. So just remember, you always read right to left. You do not look at if the arrow is pointing up or down. You look at which direction you're reading the graph from as you're looking at the x-axis. Okay. Now, we want to learn how to draw some of these things. And when we look at this, the first thing we're going to do is where the slope is less than 0, greater than 0, or equal to 0. So where is it increasing? Where is it decreasing? And where is it constant? So your constants are your turning points. So if you look here, this is 0, this is 0, and this is 0, correct? So my slope here is equal to 0 of these lines. All right, so we are constant. Oh, that did not write well. Okay, now if we draw a line here, a tangent line, our slope would be going up, so this guy is increasing. If we draw a tangent line here, our slope will be going down, so this guy's decreasing. Again, tangent line here, increasing. Tangent line here would be, whoops, come on. Wow, that's terrible. Decreasing. Please draw better than me. I will get good at this at some day. All right, so we're going to test our intervals because our first derivative tells us which way it's going, if it's increasing or decreasing, or if it's equal to 0. And that's what we're going to do here. When we find these critical points, all right, where it equals to 0, okay. We're going to actually plug those back into the regular function to figure out where those points are at on our graph. So make sure you have a calculator out. We will be using the table mode on it quite a bit to make it work. Okay, label the critical points on the graph. FC is a, okay, so if FC equals 0, so if it actually equals 0, this is a turning point because it's either the top or the bottom of a wave. Okay, if FC does not exist, then this is a horizontal asymptote. Remember, the ones that go like this? So if it doesn't exist, that's a horizontal asymptote. We don't get too many of those. We will get a couple. All right, to find the critical points from the equation, we're going to locate the critical numbers on the x-axis. Here's my pen, right here. We're going to plot the y value of the point. So we're going to actually plot the point. We're going to test x values on each side to see if it's increasing or decreasing. And we're going to plot points in each section and sketch the graph. We're going to state open intervals where the graph is increasing or decreasing. So we're going to label them. Nothing too awfully rough here. Okay, when I look at this, this is an x cubed graph, 2/3 positive. So I know this is an x cubed graph ending up. You should know in your mind that it ends like this. That's what we're looking at here. Now, we have to do the first derivative because the first derivative gives us our turning points. So we take 3 times 2/3, which is 2, x squared minus 2x minus 4. After you get the derivative, you set that equal to 0. So I'm going to divide everybody by 2 to make this easier to factor. That's an x squared. So that's x squared minus x minus 2 equals 0. And that's going to factor into x minus 2 and x plus 1 So my critical points are going to occur at 2 and at -1. Actually, right here, I like to actually plug those into your equation. I know it's later on in the thing, but since I have them and it's fresh in my mind, sometimes that's helpful. So I'm going to go to 2 and -1, so we're going to plug 2 into your original. This is where I want you to use the table mode on your calculator, if you have it, and then you're going to put it on ask, so you can put in the 2 and the -1. So what you're technically doing if you do not have the table mode on the calculator is you're finding f of 2. You're saying that is 2/3 because we're using the original right here, not the 2 cubed minus 2 squared minus 4 times 2 plus 2. Now, if you have the table mode, you just type that in and you're done. If you don't have the table mode, you got to do this each time. And when I do that, I get a -4.7. So my first point is going to be 2, comma, -4.7. Whoops, 7. And then I'm going to plug in the -1. I'm going to use the table mode on my calculator. If not, you're replacing all these 2's with a -1 on your calculator. And when you do that, I get 4.3. All right, I'm going to plug these. I'm actually going to put these on. I'm going to go to 2, -4.7. So let's graph these things right here. And we're going to go to -1, 4.3. Maybe. Come on. Maybe if I put an X at a graph. 4.3. So we got our 2 critical points graphed. Those are going to be our turning points. Okay, the next thing we want to do is we actually want to graph the y-intercept. So I know it says test a point in each section, but I would like to graph the y-intercept. And I know the y-intercept is the c value or the last value, which is a +2. So the y-intercept is 0, 2. So I'm going to go to 0, 2, and I'm going to put a dot. All right, I can graph this right now because we already know just by the positive value what it looks like. But if you don't, because you will have some graphs that are not this easy, we're going to test a point in each section to see what actually happens. So we have -1 on our graph and 2 on our graph. Now, if we test a point in each section, say we test -2, 0, and 3. Okay, and we're going to plug this into the first derivative. Is which ones we're plugging this in. So now when we plug -2 into the first derivative, so we're using this guy, well, with the 2 in front before we divided. You would plug -2 in your first derivative, and when I plug that in, again, I'm using my table mode on my calculator to make life a little easier. So what you're actually doing is 2 times -2 squared minus 2 times -2 minus 4. And I got 8. So the 8 is positive, so this means it is increasing. When you plug in 0, you're going to get -4. So since this is negative, it is decreasing. And then when you plug in 3, I got 8 again, which is positive, which means this section of my graph is increasing. So we go increasing, decreasing, increasing. So if we look here, I would go increasing to this point, decreasing through my y-intercept to my other one, and then it started to increase again, which is exactly what we thought our graph would look like. So now if we had to do this here using interval notation, we would say from -infinity to -1, it is increasing. From -1 to 2, it is decreasing. And from 2 to +infinity, it is increasing. All right. If you have any questions, make sure you're posting them or pause and actually read your book. It's got the same stuff, which would help you out also. All right. Pause the video and do yours. Oh, that one jumped a long ways, didn't it? Okay, here's yours. Your first step should have been to say, okay, by looking at this without any work, you already know the y-intercept equals 10, right? Because it's the last number. So we're going to say 0, 10, and I can plot that one and never have to think about him again, which is what I'm going to do. All right, so now let's do the first inner. So we got negative 3x squared minus 4x plus 15. All right, I need to see where this thing can do, and this actually factors because you take negative 3 times 5, which is a negative 45. So I know that that's negative 3x squared minus 9x plus 5x plus 15, because minus 9 plus 5 is your negative 4, and they multiply to the negative 45, just in case you forgot. Group the first two and the last. Let's take out that negative 3x. So that's x plus 3. Let's take out that 5. We also get x plus 3. So this factors into x plus 3 and negative 3x plus 5. Okay, in doing this, we know x equals negative 3 is a turning point, and x equals a positive 5/3 is the other turning point. All right, so now we're going to take those two and plug them into your original so you can get those points. I don't know if I want to do original or show you increasing, decreasing first. It doesn't really matter which order you do it as long as you do both. So let's do increasing, decreasing first, just so we kind of get the clue. All right, so on here we have negative 3 and 5/3. So the points I'm going to test is we're going to test negative 4, 0, and how about 2? So if we plug negative 4 into here, because this is my derivative, so this would be negative, and this would also be negative. So negative times a negative is a positive. So that means this guy is increasing to negative 3. If you plug in 0, we get 3, which is positive, times a positive, which is also positive. Okay, I messed up right here, and I'm sorry. Negative 4, when you plug in a negative 4 here, well, that gives you negative 1. But when you plug in a negative 4 here, that's 12 plus 5, which is a positive number. So we got a negative times a positive, which is a negative. Sorry, we're too far in for me to re-record. So this is negative, which means he is decreasing here. So he's descending, ascending, or decreasing, increasing, and then you plug in the 2, you get a positive times negative, which is also decreasing. Now let's find our points. So the next thing we need to do is plug in our points into our original function. Remember, not the derivative, because I don't care about slope right now, I care about points. So we'll plug it into f of x. So I'm going to plug in f of negative 3. I would use the table mode on my calculator. If not, you're doing this times negative 3 cubed minus 2 times negative 3 squared plus 15 times negative 3 plus 10, and that equals negative 26. So this point is negative 3, negative 26 that we must graph. So that's like way off my graph here. I'm just going to put a dot, and we're going to label him 26. And then the next point you're going to plug in is your 5/3. So you're going to do f of 5/3. Again, I used my table. You're plugging 5/3 into these 3's here. And when you hit enter, I got 24.8. So the next point you're going to graph is 5/3, comma, 24.8. Let's go back up here. So now we got negative 3, negative 26, 5/3, so 1 2/3, and way up here to your 24. Wow, this is not wanting to write. 24.8. We've got our y-intercept here. We know we are decreasing. I don't know why these are not staying. So, ew, wow. Okay, I don't know why this is not working. That's okay. Sorry, guys. Okay, so we know it starts off decreasing, then it turns around and increases. It goes through our y-intercept, it goes back through our other turning point, and there's our graph, which is not even close to on here, but we are good. So you found your increase and decreasing sections by plugging into f prime, and then you find your actual points by plugging it into the original function. Okay, let's move on. Undefined critical points. These are when things don't work. So you're looking for when it turns out to be something you cannot do, like the square root of a negative, or if you're dividing by 0. Those are undefined, and it helps us shape our graph. So when we look at this, we know 2x plus 4 to the 2/3. There is nothing wrong, right? So I know I can go from negative infinity to infinity. We're okay. But when I take the first derivative, so we take the 2/3 out front, right? Original, subtract 1, which is negative 1/3, times the derivative of the inside, which is 2. This gives us this for our first derivative when we move the negative down to the denominator. Well, here we know we cannot divide by 0, which means when we set this equal to 0, we have 2x plus 4 basically equals 0, so x cannot equal negative 2. All right, since it cannot equal negative 2, that's undefined at that point, this is an asymptote. All right, it is not a turning point because it is undefined. Okay, to find this, okay, so now if we plug negative 2 into our original, we're going to get negative 2 comma 0. We're going to plot this point. So we're going to go to negative 2, 0, which is, let me get down here. All right, negative 2, 0, right here, which is a little bit weird. It's undefined. I know that it can't equal negative 2 for a turning point. So something is weird, right? And it's not technically an asymptote either because it goes through there. But wait till you see what happens. It's quite interesting. So now we're going to take negative 2. We plotted negative 2, 0. Now let's check. We're going to go negative 2, right? So here's negative 2. We're going to check a point, whoops, a point on each side. So we're going to check negative 3 and negative 1. Now when I plug negative 1 into my derivative, so this is our first derivative, right? I get 1.1. So if this is 1.1, that means it is increasing because it's positive. When we plug in negative 3, I get negative 1.1, which means it is decreasing because it's negative. But negative 2 is our asymptote or turning point. So what's going on? All right, so let's just plot a point here. So if we plot 2, negative 1, if I plug in negative 1, I actually get 1.6. So we're plugging this into our original. And I'm going to plug in negative 3 into my original. And I also get 1.6. So if I go to negative 1, I get 1.6. If I go to negative 3, I get 1.6. It says it's decreasing here. So if we go start here and we go decreasing, and then if I hit here, it turns around and it starts to increase. Isn't that cool? So now we actually have a wave on both sides that comes to a turning point. All right, and the reason it doesn't have a derivative is there's no way to get a line through there. We don't know if it goes flat. We don't know if it goes this way or this way. It's not possible. Very neat. I love these kind of fun things. All right, pause and try yours. All right, I hope you did a good job. The first thing you should have done is done your first derivative. So when you did your first derivative, you have 2/3 x minus 1 to the negative 1/3 times 1 because that's the derivative of the inside. Now I put the 1/3 down to the denominator. So this is our first derivative function. Okay, we set this thing equal to 0, but that doesn't really happen, right? But it's undefined when the denominators are 0. So we take x minus 1, we set it equal to 0. So x cannot equal 1. All right, so that means that there's no derivative at 1. So either it's an asymptote or like a hole, or it's a turning point. Not a curved one, but one that actually comes to a point on the graph. So we got 1. We plug 1 into our original to see what our point is. And when we plug 1 in up here to our original, 1 minus 1 is 0, so we get 0. So 1, 0 is our point that we're looking at. So now we got to check something on both sides of 1. So I picked the 0 and 2. We plugged it into our first derivative. And when you plug 0 into here is where you're looking. You plug 0 here, negative 1 to the 1/3 is negative 1, so negative 2/3, so it's decreasing because it's negative. Plug 2 in again to the derivative, and you get 2/3, so it's positive, so it's increasing. So I know it is going down here and up here. All right, let's plug a couple points here. I plugged 0 into my original, and I got 1, so I plotted it. And I plugged 2 in my original, and I also got 1. So then when you go this, it's decreasing, so it's going down to 1, and then at 1, it starts to go back up. Again, no derivative because we have a point. There's no way to draw a tangent line at a point. Well done. All right, no critical points. Let's see, how much do we have left here? I think we'll finish off. If you want to take a break right now, that'd be okay and come back to it. So remember asymptotes. So let's go here. We have negative 2x plus x plus 2. So we're going to have to use our quotient rule in order to find the derivative. So we take the derivative of the numerator, which is negative 2, times the denominator, minus the derivative of the denominator, which is 1, times the numerator, all over denominator squared. Now let's just do that math. So you got negative 2x minus 4 plus 2x. 2x's are canceled. We got negative 4 over x plus 2 squared. Again, can't divide by 0. So go x plus 2 equals 0, which means x cannot be equal to negative 2. It's undefined here. All right, if I plug negative 2 into my original, right? So if I go negative 2 times negative 2 over negative 2 plus 2, we have division by 0. All right, this time it's not tricky. There truly is just a straight asymptote here because it cannot be defined. So we go to negative 2, and we draw in our asymptote since it's undefined at that point. Okay, so now I got an asymptote. If you remember, your horizontal is most important over most important, which is your h. So we got negative 2x over 2, so we got a negative 2 horizontal. So this should help us graph our graphs. So now that I've got the negative 2, I need to check something on both sides, right? So you are looking at your graph. Here's negative 2. We're going to check negative 3 and negative 1. All right, so we're going to plug this into our f prime, excuse me, and we get negative 4. So this guy is decreasing on this side. We plug in negative 1, and we also have decreasing. Okay, that's something new. We've never had 2 decreasing before. All right, so since that's a little bit hard, we're going to plug negative 3 into our original, and we get negative 6. So let's plot negative 3, negative 6. Right here, he is decreasing, which means he starts high and ends low. Okay, that kind of makes sense, right? Now let's plug in negative 1, and we get 2. He is also decreasing, which means he starts high and he ends low towards our asymptote. I know you could have graphed that without the derivative, but I'm hoping that helps that make sense. Okay, pause and try yours. All right, I hope you did a good job. The first thing you should have done was your first derivative using your quotient rule. So the derivative of the numerator is 1 times x plus 1 minus the derivative of the denominator, which is 1 times x minus 1. You've done all your math, and your, I should have wrote this down, first derivative is 2 over x plus 1. Cannot equal 0 when x plus 1 equals 0, so x cannot equal negative 1. When we plug negative 1 into our original, we also get a 0 here, which indicates we have an asymptote at negative 1. So we draw him in. Your next step is to find your horizontal. So you take x over x, which equals 1, and you draw in your horizontal. Okay, now we have to check at negative 1. So negative 1 is here. So we're going to check 1 on each side, negative 2 and 0. When we plug these into our first derivative, we get 2 for negative 2 and 2 for 0, which means they are both increasing. So they're both going up, which is a little helpful. When we plug negative 2 into our original, so now you're at your original function, right? You get 3, so you go negative 2, 3. So I know that this graph is increasing, so I start here and I draw it in an increasing motion. And then we go 0, negative 1. This side is also increasing, so we start low and we go high towards our asymptote. And there is your hyperbola, if you remember what those are called. All right, some things to remember. The graph is increasing on every interval, even though f of x equals 0. You know your x cubed. I know you know. So you start at 0, and remember he went up and he went down. You know what this looks like, but let's look at y. So now when you do your first derivative of this guy, you get is equal to 2x squared. When you set that equal to 0, you get x equals 0, correct? Well, when you plug x equals 0, that's a turning point, sorta, but it also happens to be your x-intercept, so it's doing everything. So here we've got, oh, I wrote that down wrong, 3x squared, I'm sorry. Still get 0. So then we have, when you set this equal to 0, you have x equals 0. All right, we know that that is good. Now we got to check something on each side. So we're looking at 0, so let's check negative 1 and 1. When we do f prime of negative 1, okay, that's going to give us 3. And when we do f prime of positive 1, we are also going to get 3. So it is increasing on both sections of the graph. All right, but now when we do go back to your original, f of 1, so you're back here, you get 1. And when you do f of negative 1, you get negative 1. So negative 1, negative 1, 1 and 1. 0 is a turning point, increasing always. So I start here, I have to go in an increasing section, hit my turning point, and continue in an increasing section. So it is possible to have two increasing sections next to each other. I don't think that that is not a possibility. All right, good luck on your homework. Make sure you're posting questions with pictures so I can see where you're stuck, and do a great job.